My name is Ace McNeil, and this is a short lesson on the independency and dependency of probability variables. In addition, I will talk about how probabilities A and B occur, and how the relation to probability A given B. To start off, let's talk about the independency and dependency of variables A and B. Now, the example that was taught about in my statistics course covers coin flips. Now, probability A states a coin flip will land on A. And this is the second. Let's be clear, this is the second coin flip. Now, probability B states the first coin flip also lands on heads. The reason this is an independent variable, the coin flip of A, which is heads, does not change no matter what happens with probability B. If it also lands on heads, whether probability B's coin flip lands on heads or tails does not matter. The probability of A will the coin flip will land on heads will stay the same. When it becomes dependent, this is a little bit of a more broader example. That was also in our statistics notes. Excuse me. It talks about house fires and ice cream sales. Now, probability A states it states a low probability of house fires in a given neighborhood. Now, probability B states a high probability of ice cream sales. Now, if we know probability B exists, there's a very high probability. There's a very low Now, excuse me. If we know that ice cream sales are high in a given neighborhood, that means that house fires, there's a very low probability that house fires occur. So high sales in ice cream mean low house fires. Hope you got that example. It's a bit tricky to comprehend at first in my class. Now I want to talk a little bit about the relationship between probabilities A and B occurring and probabilities A given B. Now, probability A given B still equals A, as I taught about, because they are independent. Probability A, because they can't be independent. Now, probability A is not affected by what happens with probability B. In the equations, probability A and B equals probability A times the probability of B. Whereas is written in the notes, probability A times the probability of B given A, which is still the probability of B. As we looked at this and talking about my test earlier this semester, we were tasked with writing a two-way table and talking about testing for the probability of scoring a scholarship for a state or university scholarship. Now, the way I wrote the two-way table was upside down and inversed. So instead of writing the probability of each event occurring, I wrote the total probability of each event occurring. As you might imagine, I wound up missing on 3 parts of the 5-part question. In reality, it's very important when doing probability tests to write the two-way table correctly. This is of course imperative when talking about probabilities A and B occurring and doing that equation, because probability of A and B occurring equals probability A times the probability of B given A, or probability of A times the probability. Let's flip that. It's probability of B times the probability of A given B, which is still the probability of A. So, whenever time a professor asks you a question, either on a test or exam or even a lab, and you're tasked with doing a two-way table, that's the most important thing, because without doing a two-way table, you're going to wind up messing up on the questions after the fact. So, hope you are now a little bit more educated on probabilities. My name is Ace McNeil, and hope you have a wonderful day. Thank you.